Hello, welcome everybody. My talk today will be about infrastructure modernization on GCP. My name is Narish Samplay. I'm UK CTO of Dev Team G Cloud. I am Google Cloud Certified Fellow in Hybrid Cloud. There's around 100 globally, and it's very hard to pass certification. And I have 20 years industry experience across public sector and financial services. And moving into a Dev team, I'll be able to leverage that experience across digital natives and fintechs and other industries. So today's agenda, I'm just going to talk through a few topics that I feel are most important when it comes to infrastructure modernization. So I'll start off with cloud journey, foundations, application onboarding. Also be talking about the engineering workflow, which is very useful when you are trying to adopt cloud at scale. And also look at the migration strategies and accelerators. And at the end, I'll finish off with some Q&A. So moving to the cloud is a journey. Some customers will take months, some will take a few years, and most customers that have existing on-prem environments will go through a journey which will cover discover, plan, migrate, and optimize. So in this space, when we do a discover, we have various tools available to us. So as part of Google Cloud, we have Stratozone, which is a tool which can do an audit and a data collection on your existing estate. If you've already got a virtual machine environment estate, it can probe that and produce reports which will hope to identify the best workloads to migrate to the cloud, and also what the potential costs are over a 1 or 3 year commitment. And armed with that information, you can then move on to the next stage, which is to plan. As part of the plan, you need to look at your foundations, which is your GCP landing zone. Foundations typically can take 6 weeks to 3 months, and there is a process that we go through, which entails doing workshops with yourself to elucidate your requirements across the various pillars to build and design the foundation to your requirements. And for more regulated industries, the foundation can take 6 months to a year in some cases, where you have a lot of regulatory requirements to meet. And then we move on to the migrate stage. If you already have an estate already on-prem or in another cloud, there are various tools available. So in this space, we have Migrate for Compute Engine, which allows you to take your existing virtual machine VMware workloads from your existing environment and move them into GCP as VMs. We also have Anthos Migrate, which allows you to take those existing compute workloads and migrate them to GKE. And if you want to, should you wish, to deploy Google Compute VMware Engine, which is a new feature, you can also use VMware to VMware migration to take those existing VMware workloads and migrate them to a GCP flavored VMware environment in the cloud. And that's something that we have done for many customers across Europe. And I myself was involved in one of those migrations, and it was very quick and fast. And then the business value you really start to achieve is when you hit the optimize phase. So the simple workloads you've migrated to the cloud, but once you start optimizing into serverless and cloud native technologies and moving away from infrastructure as a service and moving more to serverless in the sense of cloud run or cloud functions, or even going towards GKE autopilot, is when you start to really pick up on the benefits of migrating to cloud. So, on my last slide, I talked about the cloud foundations, and the cloud foundation is very important. It is your GCP deployment in terms of your organization, your folder structure, your projects, and this is where all your GCP resources will be deployed to. So what we do is we run through various workshops for over a couple of days, which cover all of these topics, starting at identity and access management. So in that instance, we will talk to you with about your identity provider you currently use today, what your single server sign-on requirements are, because the idea of using cloud is to make it as seamless as possible, and this is key to adopting cloud at scale. So when you have identity provider set up, that allows your teams to be able to be given access to GCP, Google Workspace, and even other SaaS services using the single sign-on approach. We move on to billing. All GCP consumption is recharged through the 30-day invoicing, and all that information regarding consumption is held in a BigQuery database. And in order to drill down on consumption and to provide you with the information required to recharge it to various in-house teams, the billing side needs the appropriate tags added to the GCP resources. So once that's in, you can find out who's using what across your estate and give you that insight into your GCP consumption. Moving on, there are other topics to look at, such as KMS, logging, monitoring. The benefits of all of these are all built into GCP, and there's lots of documentation around best practices and what features you should and shouldn't enable. Monitoring is built in to GCP, so all services and resources inside GCP log to cloud logging, and that is retained for a default retention period, and you can increase those metrics. If you have particular regulatory requirements to export all of that information to a specific CM tool, all of that can be tweaked, and the best time to do that is when you're building your foundations and before you have your production workloads running in your environment. One of the best concepts around GCP is the shared VPC model. So you allow one network to be created, whether it be a non-production or a production network, and that network then is used by all your GCP workloads, whereas other hyperscalers restrict you to using one VPC per account, which makes it a bit tricky then to integrate that into your on-premise systems. And then the last bit is around security. So security is important in the cloud, and there are various services in GCP, such as Security Center, Command Center, that allows you to have that telemetry around your GCP consumption. And the last thing I was going to talk about, which isn't on there, is around organization policies. So these are policies that you apply at the organization level and at the project level, which enable or disable certain features, such as disabling the use of public IP addresses inside Compute VM. You can do that. You can set an organization policy, and that will then block any workloads from using a public IP address. The next topic I wanted to cover was around application onboarding. A lot of the time, and clients I've worked at, they focus on provisioning a GCP project, but a GCP project in itself is not enough for application teams to consume cloud at scale. So the idea with this application onboarding workflow is you can have lots of teams who don't know much about GCP, they don't have lots of infrastructure as code, Terraform, automation experience, but you want them to work in a secure and protected manner, and give them an environment where they can deploy into production but not have workloads that don't abide by your security best practices. So this workflow is two stages. When an application team requires a GCP project, as part of that workflow, you provision service accounts, these service accounts have permissions to run the next workflow, which I'm going to come on to on the next slide. You can enable and disable specific APIs. So Google services inside GCP are an API. So if you want to use GKE or BigQuery, these are all APIs. So as part of this workflow, you can enable it, you can create KMS keys, you can label it, and you can make sure the projects are all conforming to your naming conventions. And then from a FinOps perspective, you've got a standardized labeling across your whole GCP project estate, and then attaching the project to the shared VPC is a privileged action. So all of these privileged actions are all happening at one time, which means that when the application teams need to start deploying anything into GCP, all of this plumbing has basically already been done. It's using best practices, it's standardized, and you can potentially even integrate this into your IT service management tool of choice, so that through an IT service desk request, you can onboard this workflow. And the additional bits to this workflow is things like you can provision Git repos, you can provision a Terraform workspace, even you can go down to the level of creating groups, security groups as well. So if you've got a very sophisticated and mature end-to-end onboarding process, which covers GCP project creation, your Git repo, your Terraform workspace, your security groups, it means that you can have lots of application teams really increasing their velocity when it comes to cloud consumption. And when I move on to the next slide, anything they do is now using a limited privilege service account, which you've already created in this application onboarding process. So if, for instance, your particular use case is only allowing use of BigQuery and Google Cloud Storage and Compute VM, you can limit the CI/CD service account to just use those services, which is the topic of this next slide, which is the engineering workflow. So one of the most agile ways of working, which allows you to also comply to your organization's security standards, is using Terraform as your infrastructure as code tool of choice, and then using not the open source version, because I feel that's a bit limited, but using the paid-for SaaS offering called Terraform Cloud, which has additional enhancements, such as it's got single sign-on in there, it's got cost estimation in there, it has a SecOps feature in there, and it also has a new feature in there called Run Tasks, which allows you to integrate into third-party tools. Now, obviously, you can do all of this with the Terraform open source product, but that means you've got to evaluate various tools. You've got to decide, are you going to use Chekhov, are you going to use TFSec, are you going to use ConfTest? And you've got a lot of work and discovery to do. Whereas if you just use one tool, keep it simple, use Terraform Cloud, use all of the built-in features that it provides, it means that you can hit the ground running, faster time to production, and you haven't got rogue developers who can comment out steps in your CI/CD pipeline. Because when you're using Terraform open source with, say, GitLab CI/CD, that YAML file which defines your CI/CD process is part of your Git repo, and anyone in your team can choose to comment or uncomment parts of that pipeline. So the benefits of Terraform Cloud is all of your CI/CD is now running in the cloud. Your Git repo is connected to a Terraform Cloud workspace, so you have a single dashboard of changes being made to your environment. And the first step you do is, as a developer, I want to deploy a resource into GCP. You make the changes in a branch, you raise a pull request. That pull request kicks off a speculative plan, and then that can now be reviewed by another member of the team who has the appropriate permissions, who can then approve that, and then once that's approved, you can then merge that and apply that, and then when Terraform executes that, it will go through the Sentinel SecOps, and with Sentinel you can do granular enforcement, such as these users cannot deploy anything above an N1 instance type, or they can't deploy any services without a CMET key. Now, CMET key is something that Google organization policies now caters for, but what Sentinel does is it allows you to have those granular security policies in place. And in other organizations before this in pipeline SecOps came about, used for SETI security scanner, but that is post-deployment, which means that it's reactive. So you could deploy resources into GCP, but they wouldn't abide by your corporate security standards, and then you'd get an email from SETI advising that you'd breached some policy. So this engineering workflow provides an easy-to-consume model and really accelerates cloud and means that teams can make use of existing assets that you have in-house in terms of code libraries. And if everybody can see your code libraries in-house, it really allows teams to hit the ground, look what other use cases are in the organization, and everybody's working to the same methodology and approach. Where you have hybrid working, you've got remote workers, you've got permanent staff, you've got contractors, freelancers. This workflow means that everybody can see what is happening in the environment. Whereas if you let people deploy things using ClickOps, which is manual, you don't have much control, and people are spinning up workloads that are then not easy to reproduce as you move from dev, staging, UAT, production. So this slide was around the migration strategies. So we talked about the discover and plan phase in my earlier slides. So when you have existing workloads on-prem, you have basically 6 options. We call it the 6 R's, and they are retire, which essentially means that these workloads are not going to be moving to the cloud. Maybe they're running some legacy software. Maybe the use case is no longer needed. Or for instance, it's retained. There is a specific business case which requires these workloads. Maybe it's data residency, it's to do with latency, that they have to stay on-prem. And then the next option is rehost, which is the simplest. For instance, you've got some VMs running on-prem. You can easily lift and shift them into GCP using the tools I talked about before, such as Compute Engine for Migrate, or if you're using VMware, you can do a simple VMware to VMware migration using the HCX. And then you've got replatform. Replatform allows you to change small parts of your application architecture. So you can move the compute VMs as is, but you may choose to move the database persistence layer into, say, Cloud SQL and take advantage of the PaaS offering. And then you have refactor, and refactor is where you can then really optimize your workload and start taking advantage of cloud native. So if you've got a on-prem workload right now, you can take that as a monolith and then try and refactor it into a microservices based architecture and look at things like GKE Autopilot, which is the more sophisticated flavor. You've also got Cloud Run and other cloud functions as well, should you choose to use them. So accelerators is something that a lot of companies talk about, and it is an in-house asset library of reusable artifacts, and it really accelerates cloud adoption because you have a whole team of engineers contributing towards these assets. So when Dev team do engagements, we find that we are doing similar things across many of our clients. So for instance, foundations, many of our clients want foundations. So we have a cloud foundations accelerator, and when you do data, we have similar concept there. And as more and more people are working with clients, we try and build this asset library, and we share that with the clients, and the value we bring as a reseller and a partner to our clients is by having this reusable asset library to accelerate your adoption of cloud. And we cover multiple strands. So we cover AI, we cover app modernization, we cover infrastructure. So we have a growing number of assets in our library that we can use to optimize and accelerate your cloud adoption. So that's the end of the slides that I want to cover today. Is there any questions? Yes. So on this slide here, we talked about cloud foundations. We have data foundation, data accelerator, which we'll be talking about this afternoon. We also have a FinOps accelerator, which we use to optimize GCP consumption. So that is more of a process in terms of optimizing spend in your GCP estate. We also have one around Anthos. So Anthos is a suite of products around Kubernetes and on-prem and Kubernetes in the cloud. So we do have assets around that, and a lot of customers who want to consume those type of services, we have assets ready to go. We also have GKE, so everybody who wants to use GKE needs to use it securely. Out of the box, it comes with a control plane that can be public or private. So we have an accelerator ready to go, which we have all the built-in security. We have the policies in place so that all the plumbing and all the best practices and the built-in guardrails are all there. Any more? Google Kubernetes engine. So Kubernetes is the containerization distro that Google worked on, and the Google flavor is called GKE. Azure flavor is Azure AKS, and the Amazon flavor is EKS. So a hyperscaler are like your cloud providers that allow you to use compute and other services at scale. So in the olden days, you had private cloud and on-prem, but that was very much fixed capacity. So you'd have to order servers, you'd have to order racks, you'd have to get network teams to plumb it in. Now you have the hyperscalers who do it all for you as part of the shared responsibility model. So you only need to pay for consumption. You don't need to feed and water tin anymore like you had in the past and be up on weekends patching it and upgrading it.
So it's the cloud providers.
Yeah. Any other questions? Cool. Thank you for your time, and look forward to speaking to you in the break.